Find the maximum and minimum values of the objective function z equals 3x plus 4y on the region defined by, maybe I shouldn't say bounded by, let's say defined by. I don't know if this is a bounded or an unbounded region. In any case, we have 4 inequalities here, and we're saying that they define a particular region. We need to decide what is the maximum and minimum value that it can be of this objective function within that region. So the first thing we'd want to do is graph the region to see what we're talking about. I'll call these lines 1, 2, 3, and 4. And the first thing I'll do is figure out where my, I'll figure out some things to graph these. This first line, yeah, sure, why not? I'll do 0, 5, and if y is 0, I get x is 5/2. Or 2.5 if you want to write it that way. That might be easier, especially since we're drawing a graph, 2.5, 0. All right. Let's test the origin. I know it doesn't go through the origin because neither of the intercepts are the origin, so I know that that line doesn't go through the origin, so I can test it. I get 0 plus 0 is greater than or equal to 5, which is false. So whatever we, when we go to graph this, we're going to be shading away from the origin. I'm going to do this for the other lines as well. Let's see, if the x-coordinate is 0, this is x plus 5y equals 16. If the x-coordinate is 0, I get 5y equals 16. So we get 16/5, but that's kind of weird writing it like that, so I'm going to do 0, comma, and actually perform the division on a calculator or something like that, 3.2. It's much easier to figure out where it is using decimal, so that's what I'm doing. Then we get 16/0 for the other intercept. Let's test the origin. 0 plus 0 is greater than or equal to 16. This is false, so we would shade away from the origin on that one. For the third line, we get 2x plus y is less than or equal to 14. I'll pretend that's an equal sign while I'm doing my while I'm doing my boundary line. If x is 0, I get y equals 14, so that's 0, 14. If y is 0, I get x is 7, so that's 7, 0. Let's test the origin here. We get 0 plus 0 is less than or equal to 14, that's true. So we'd shade toward the origin on this line. And the final line, I'm kind of doing all this stuff ahead of time to make graphing a lot faster. The opposite of x plus 4y is less than or equal to 20. If x is 0, I get 4y equals 20, so y would be 5. And if y is 0, I get the opposite of x equals 20. So that means it looks like x would be negative 20. Let's test the origin here. If I plug in the origin, 0 plus 0 is less than or equal to 20. This is a true statement, which means we'll shade toward the origin on that one. Okay, so all of that is to make it so I can graph this with relative ease. It's also nice finding out all my corner points before I start any graphing to make sure that all my, not my corner points, all my intercepts, to make sure that all my intercepts show up on my graph. You can see I go all the way up to 20 here, I have a 14 there, I have a 16 here, so I want to make sure my scale allows for that stuff. So let's call this 20, which means that's 10. These are 5s. So 5, 10, 15, 20. 5, 10, 15, 20. There should be negative 20 over here. And 5, 10, 15, negative 20. Okay. First off, I have the point 0, 5, which is up here, and 2.50, which is over here. When I'm drawing these lines, I'm going to do my best to keep them nice and straight. I also want to make sure they extend through the entire window, because I want to make sure that when I'm drawing my other lines, I can kind of see where they intersect. I'm going to label this as line 1 so I can tell which line it is later on. And I know I'm going to be shading away from the origin on this one because 0, 0 did not satisfy it. So I'm going to do a little arrow pointed away from the origin down here. That's when I say away from the origin, it's to the right of this line. All right, for line 2, I have the point 0, 3.2. It's about there. I'm just kind of estimating. And 16, 0, which is over here. Looks about like that. I can do better than that. Oh, that's pretty close. I'll call that good. That's line 2, and I would shade away from the origin on this line as well, because it did not satisfy the inequality, or the inequality did not satisfy it. I should say. All right, 0, 14 is up here, and 7, 0 is over here. I can do better than that. Let's try like this. There we go. That's my line 3. And I should shade toward the origin for this line. It'll look something like that. And my last line is we have a 0, 5, which is right there, and negative 20, 0, which is over here. So when I draw this one, there we go. That looks like it goes through those. I'll again shade toward the origin, which is in this direction. All right. Let me zoom in a little on this, and let me figure out where our feasible region is. That is where we satisfy all 4 of these inequalities. We need to be between these lines, and these look like they might be parallel. I'm not quite sure at this point. Let's see. We need to be below this line and above that one. So it looks to me like we should be in this region right here. So that means, let me label this as line 4. That means that our corner points are here, 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 and here. Let me choose a different color. Here's a corner, here's a corner, here's a corner, and here's a corner. Those points we need to find the coordinates of. Alright, well, if only we knew how to find the intersection of 2 lines. Well, this point right here, I'll start with that one because it's the intersections of line 1 and 2. You can see how convenient it is that I've labeled that this is line 1 and that this is line 2, because then I can say that this point is at the corner, the intersections of lines 1 and 2. If I'm finding the intersection of these 2 lines, well, let's look to see what their equations are. We have 2x plus y equals 5. And for line 2, x plus 5y equals 16. If only there was a way to solve a system of equations like that. This is 2 equations with 2 unknowns. And, well, I mean, there's other ways of going about this, but we've seen how to use a matrix to solve a quick system of equations like this. So let me go into the matrix menu. I'll go over to edit. This is a 2 by 3 matrix. I'll just enter my coefficients here and quickly run RREF. On matrix A. We get the point 1, 3. So that's this point. That's one of our corner points. This corner point right here is actually really easy. I already know that both lines 4 and 1 contain the point 0, 5. You can see 0, 5 is right there, and 0, 5 is right there, so that must be their point of intersection. So 0, 5. You'll notice I didn't just... It's not generally a good idea to guess at what these points of intersection are based on your drawing. It definitely is a good idea to go through this process of using our matrix to find the intersection of the 2 lines. I would recommend, once you kind of start working on this, go around in a either clockwise or counterclockwise direction. Because now that I've entered, well, I have entered in lines 1 and 2 into the matrix, and for this, when I figured out this point, if I go and figure out this point next, this one would be lines, what is that, 3 and 2? Well, I already have line 2 entered into that matrix. It's already x plus 5y equals 16. So I would actually only need to change one of these equations. 2x plus y equals 14 is equation 3. 2x plus y equals 14. So I can go ahead and alter that matrix. I only need to change the first equation. So 2x plus 1y equals 14. And I can quit out, run REF again. This is the 0.62. That's where that point is. That's the 0.62. And then lastly, there's this one here. Let me go like this. This is at the intersections of lines 3 and 4. This one right here, this equation is line 3, so I'll just copy it down. And when I edit my matrix, I won't need to change that one. 2x plus y equals 14. And the equation for line 4 is the opposite of x plus 4y equals 20. Go back into my calculator, edit matrix A. See, that is the equation I'm keeping, so I'll do this one, the opposite of x plus 4y equals 20. Quit out, run REF again. This is the 0.46. So that means I want to test, well, now I can test these 4 corner points with my objective function. So let me restate what my corner points are here. I have 0, 5. That was this intersection, or the intercept of the 2 lines. Next up I have 1, 3, 6, 2, and 4, 6. And my objective function, when I go to test that, is 3x plus 4y. We call it z when we're talking about the objective function. That's just a standardized letter. I'm not sure where it came from. Well, it's because it follows x and y, I suspect. Alright, so we got 3 plus 12 is 15. 18 plus 8, which is 26. And lastly, 12 plus 24, which is 36. So our maximum is right here. Looks like our minimum is right here. So this particular system of inequalities maximizes our objective function at the point 1, or at the 0.46, and it minimizes the objective function at the 0.13. But all 4 of these, or well, that entire feasible region satisfies the system of inequalities. It satisfies all 4 of those inequalities individually. These are just the maximum and the minimum values that are possible to achieve within this system.